All right, here we go. 4.2, trig functions and the unit circle. What are we doing today? We're looking at the unit circle and what that actually is. We're going to evaluate trig functions. So you know your sine, cosine, tangent, and then a couple others that you probably haven't seen before. And then looking at the domain and range of those functions and how they can help us evaluate some larger angular values. So let's start off unit circle. Boom. What is the unit circle? The unit circle is a circle based upon a single unit. So a circle with radius of 1 being that singular unit. Centered at the origin. So you know, if you wanted to write an equation for it, that's your x squared plus y squared equals 1, where 1 is your radius square over here, and then over here is your center value, x plus h, y plus k, and those two values are both 0. So centered at 0, radius of 1, unit circle. Nice and easy. Right? That is the most simplified way of talking about this circle. Now there's a lot of pieces that can get thrown onto it. There's a lot of really cool relationships that happen within this circle. We're going to start to look at some of them later. Now we've heard of sine, cosine, and tangent, but may not have heard of cosecant, secant, and cotangent. So altogether there's 6 of them. Abbreviated sine, cosine, tangent, cosecant, secant, cotangent. All right, so they all get broken down to these 3-letter abbreviations. But what exactly are these things? Well, there's a lot of different ways of thinking about them. The first way that we're going to look at them is as xy coordinates on that unit circle. Okay, now you might be used to seeing sine, cosine, or tangent involved with triangles, and we'll go into that in the next section. But for right now, we just want to look at how these things relate to a circle with a radius of 1 centered at the origin. Okay, and it happens that they relate in terms of the x and y coordinates of a particular point on that circle. All right, so let's say I choose a particular angle value. I don't know, let's just say it's 3. So at a rotation of 3, the sine value at that point is going to be the y coordinate given that particular rotation. The cosine value will be the x coordinate. And then everything after that is kind of just a relationship game, right? Because I only have x and y as my coordinate points. So there's really no more information I can take from it. The sine is the y, the cosine is the x, tangent is going to be y over x. Okay, that's a nifty new way of using information that's already there and reformatting it into something new. Cosecant would be 1 over y, so the reciprocal of the sine. Secant will be 1 over x, the reciprocal of cosine. And cotangent will, instead of being y over x, which is tangent, cotangent will be x over y. So again, the reciprocal. So each of these things are related to each other in that way. They are reciprocals of one another. So it's really not like 6 completely new things, or if you already knew the top 3, it's not that you're adding 3 new things. We're just exploring the idea of their reciprocals. I hope that everybody took that down. So, in the front of your book, you have this handy-dandy white page, which you're going to know to love, which has a unit circle much like this on it. Now, like I told you before, the unit circle can get muddled with a ton of information. The one that I showed you before only had coordinate points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But what's been added in here are all the degree values going around the circle, all of the radian values going around the circle, and now coordinate points going all the way around the circle at those specific radian values. That if you fold this over left to right, identical. Fold this over top to bottom, identical. And it's a very cool relationship that they have there. We'll get to explore it a lot more later, but for right now, all we need to do is be able to read this. Okay? I'm not asking you to dig any deeper into it at the moment. And what we want to do is evaluate the 6 trigonometric functions at each real number. So when t is equal to pi over 6, what is the 6 trigonometric functions at that number? Okay, I'm going to go to the next page because I think I have more room. T equals pi over 6. Switch back to black. Now, what does this even mean, t equals pi over 6? Well, when I was looking at all of these trigonometric functions, the t value seems to be that angle value. So when the angle is pi over 6, the sine of that angle will be the y-coordinate. The cosine of that angle will be the x-coordinate. Now let's pop forward again here. Pi over 6 is right here. So change that. Color that will pop out a bit more. Blue. So pi over 6. And so I'm looking at this coordinate point. This is the coordinate point of pi over 6. So the x value is going to be my cosine. The y value is my sine. Alright, let's just drop those in right here. Cosine pi over 6, and sine pi over 6. Right, so cosine is square root of 3 over 2, sine is 1/2. Cool. Now I have all the information that I could possibly grab from that unit circle. Now what I have to do is start manipulating things. I know, again, from the previous pages, that the tangent is just going to use y and put it over x. Alright, so y, again, was this value, so 1/2 put over square root of 3 over 2. Now, I know that I've said this before, the fraction idea is very, very important. How do I, add this in here. How do I divide fractions? Well, I multiply reciprocals, right? Hopefully everybody remembers that. So essentially I have 2 and 2, those are going to cancel out, 1 over the square root of 3. I don't like radicals in the denominator, so that is going to become the square root of 3 over 3. Fantastic. Now, how do I get the others? Well, what is beautiful about this is that, remember we were talking about their relationships with each other? Their relationships are reciprocals. We just have to remember which one is reciprocal to which one. Sine has a reciprocal of cosecant. Cosine has a reciprocal of secant. Tangent, reciprocal of cotangent. So, sine has a reciprocal of cosecant. Cosine has a reciprocal of secant. And tangent has a reciprocal of cotangent. So, given that information, I should be able to just take the values for cosine, sine, and tangent and flip them. So this one should be 2 over the square root of 3. Ugh, don't like square root of 3 in the denominator. So I'm just going to multiply both the top and the bottom by the square root of 3. So this becomes 2 square roots of 3 over 3. This one I just flip, 2 over 1. And this one I will flip, 3 over square root of 3. Ugh, square root of 3 in the denominator again. Now we have 1, 2, 3, 4, 5, 6, the trigonometric functions. Let's do it one more time.
Well, that was a great explanation.
I don't know, let's do one that's a little bit difficult. Let's do D, because that has a negative angle, and I want to do that one. So, where T is negative pi over 3. Let's write that down in here. T is negative pi over 3. Interesting. So now let's look at that unit circle again. I know pi over 3 is right here, but that's not what I'm looking for. That's a positive angle. I want negative pi over 3, which, if I go for my initial, means I need to go this way. The same amount, but I'm going to land here. So negative pi over 3 is coterminal. It's not the same angle, but it's coterminal to 5 pi over 3. And this is where we get to see the relationship of coterminal really start to mean something. All right, because they're not the exact same angle, but they are going to have the same sine and cosine, tangent, cotangent values. Okay? So despite the fact that we couldn't say that they were the same, all of the information that we're going to get from them are going to be the exact same. So let's start looking. I know that cosine is going to be my x, sine is going to be my y, so let's go ahead and write those in. And sine. My cosine value was 1/2. My sine value was negative square root of 3 over 2. Alrighty, so it looks like we're kind of using the same type of information as in the last one. The 1/2 the square root of 3 over 2. And yeah, you are going to see these types of fractions continually repeat themselves. They're in different arrangements and sorts, but that symmetry in the unit circle is going to make these things come up a lot. So let's move on. Tangent. Tangent is going to be the y over the x. All right. So remember that sine relates to the y, cosine relates to the x. So it's going to be negative square root of 3 over 2 all over 1/2. How do I divide fractions? All I do is multiply by the reciprocal of the denominator. Negative square root of 3 over 2 times 2 over 1. Cool, I have 2 and 2 that are going to cancel out. What am I left with? The negative square root of 3. Fantastic. Now it's the easy part, because all I have to do is take reciprocals. Cosine is related to secant, sine is related to cosecant, and tangent is related to cotangent. Tack in my theta values here, negative pi over 3, and we're good to go. The reciprocal of 1/2 is 2. That's an easy one. The reciprocal of negative square root of 3 over 2 is going to be negative 2 over the square root of 3. Eek! Radical in the denominator. Negative 2 square roots of 3 over 3. And, last but not least, the reciprocal of negative square root of 3 will be negative 1 over square root of 3, which I will have to rationalize the denominator again, making this the square root of 3 over 3. Phantasmal. Beautiful. Wonderful. Wunderbar! Continuing. Now let's look at the domain and period of the sine and the cosine. Okay? All those values, those values that I could put in, these t values that we were looking at before, t could pretty much be whatever I wanted it to be, right? I had a positive one, I had a negative one. These ones that we didn't do in the middle, they're in between those two values. But it could be, it seems like, any number, which is true. I can take any number and put it into the sine or cosine functions, and I will get a value, like that square root of 3 over 2, or like 1/2. So the domain of these functions is the set of all real numbers. I can put anything in there for t. The range, however, that's an interesting point, because when we look at the unit circle, it's very, very small, right? I can choose any value going around here. It can be 0, I could do pi, I could do 2 pi, I could do 3 pi, I could do 4 pi, I could do 5 pi. I can continue to go around this circle forever, and I can put it into the function, but the values that I will get out are completely dependent on the x and the y. So x can only go as far in the positive direction as 1, and it can only go as far in the negative direction as negative 1. So my cosine, because cosine relates to the x, could only be between 1 and negative 1. The same thing is going to be true for sine, because sine relates to y. It can only go as high as 1, and it can only go as low as negative 1. So the domain, the numbers I can put in, could be anything. In infinite rotations of this circle, I can put in angular values, but their sine and cosine will only always be between 1 and negative 1, and 1 and negative 1. So that's why I was saying those numbers repeat over and over, and you're going to see things like 1/2 and square root of 3 over 2 over and over. That's because these functions are periodic. They're cyclical. Okay? And what that means is that any particular function that is periodic, you can put in any value you'd like to, but if you add a specific constant to that number, you'll get the same answer as if you didn't add the constant. So, for example, if I were to put in f of pi, right, I could get a sine and cosine. I could get an x and a y coordinate. But if I were to put in f of pi plus the constant, that magic number for this is 2 pi, because 2 pi is a full rotation. If I were to put in pi plus 2 pi, I'm going to get the exact same values. All right, so that magic number, that magic constant that makes these things periodic is 2 pi, because that's one full rotation. Right? Now there's just this idea of even and odd functions. Of the 6 trigonometric functions that we have, 2 are even, 4 are odd. And we need to just remember the fact that a function is even when, if you put in a negative value into the function, you get the same thing as if you put the positive version. And a function is odd if, when you put in a negative value, you turn the entire function negative. And we can look into that again a little bit later, but just wanted to throw that in there for a second. So now let's use that periodic idea to try and evaluate sine and cosine for some values that are a little bit more strange. So if you remember back to the first video, I did something with 13 pi over 6.
Did you fall asleep?
Which was to rewrite it. Because
Are you
13 pi
falling
over
asleep
6
right
is the
now?
same thing as 12 pi over 6 plus that extra 1 pi over 6. And there was something special about 12 pi over 6 because 12 over 6 is 2. That's 2 pi plus pi over 6. Now, if I'm looking to find the sine and cosine, according to what we know already, all I need is the xy coordinate that corresponds to this angular value. Now, based on this periodic idea that we just learned, this 2 pi is that special constant number that really makes it not matter, because this should be the same thing as this, right? The values that I would get at 13 pi over 6 should be the same thing as the values that I would get at pi over 6. Let's take a look at, back a little ways, this visual here. 13 pi over 6, I'll put this one in red. 13 pi over 6 brings me around the entire circle, 12 pi over 6, and then another pi over 6. Right? So it brings me around, and then it hits pi over 6. Whereas, if I wanted to, I could just go, well, instead of going all the way around and then hitting it, it's the same thing as just doing pi over 6. So, let's head back. What are my values for sine and cosine at pi over 6? Well, my cosine value is going to be related to the x, and my sine value is going to be related to the y. My cosine value at pi over 6 is going to be the square root of 3 over 2, and my sine value at pi over 6 is going to be 1/2. Very good. Now let's look at negative 7 pi over 2. Now this one's a little bit weird. All right, negative 7 pi over 2. What is it that I could possibly do with this that could rewrite it in a way that I could kind of neglect some of these 2 pi or this period type idea? Well, let's see. Let's just split it up so that it says something like, the closest thing I can see to it is negative 8 pi over 2 plus pi over 2, right? If I were to add negative 8 pi to 1 pi, I would get 7, so I mean, this is the same thing, I've just written it in a different way. But what is negative 8 pi over 2? Why do you think I chose to do that? Well, I chose that because this ends up being negative 4 pi. And that is the same thing as saying, let's go in the negative direction twice around the circle. Whoop, whoop, and you have done absolutely nothing. You are still at the initial point. Doesn't really matter. But after that, now let's go in the positive direction, pi over 2. Now you have an angular value and a terminal sign that's not on the initial. Cool. Plus pi over 2. So, really all I have to ask myself is, because this doesn't matter anymore, because it just landed me at the initial side, what are the sine and cosine values at pi over 2? Well, that's actually one of the easiest ones. Cosine and sine, again, cosine relates to the x, sine relates to the y. The cosine value is going to be 0, and the sine value, 1. Alrighty, everybody. Do the problems that you are assigned to do. Hopefully I kept this video a little bit shorter than the last one. I will see you all in class, and take care!